So we're going to solve some more radical equations, but these particular types will result in a quadratic equation. So let me remind you how you would solve a quadratic equation, such as x squared plus 3x plus 2 equals 0. You would factor the left side, x plus 1 times x plus 2 equals 0. And then x plus 1 could be 0, or x plus 2 could be 0. So if you subtract the 1 here, you could see that x could be negative 1 or x could be negative 2. So you get two possible solutions. The reason is if you substitute negative 1 in for the x's, then negative 1 plus 1 is 0. So this purple guy is 0. So it doesn't matter what this other one is because 0 times anything is 0. The same thing if you plug in the negative 2, the second x plus 2 is 0 times this would still give you 0. So either one of these would be valid solutions. Alright, let's try to solve a radical equation. In this case, one of the radicals is already isolated, so I'm going to start by squaring both sides. And so what that's going to do is allow me to get rid of the radical on the left, because squaring the square root makes the square root go away. On this side, I'm not squaring the square root, I'm squaring the square root plus 1, so I have to multiply it by itself, and then actually multiply everything out. So I will multiply the two square roots here. When I multiply a square root by itself, the square root goes away and I get 7 minus 2y. Multiply the 1 by the 1 and I get plus 1. In the middle I get one of the square roots, and on the outside I get another one of the square roots, which gives me 2 of the square roots. So that's the right side. The left side doesn't change. Now I need to stand back and say, how do I solve this? Well, there's a term with a radical again, so I get this term by itself. So I will take, let's go ahead and do a little more work. Let's rewrite the right side. 7 plus 1 is 8 minus 2y, and then plus my radical term here. So I'll subtract 8 from the 6, that will give me a negative 2. And I'll add this 2y to this 2y, giving me 4y. And now I've got 2 times the square root of 7 minus 2y. I notice at this point that everything's divisible by 2, so I might divide everything by 2 to make the number smaller. And so I get 2y minus 1 equals square root of 7 minus 2y. And now, to get rid of this square root, I would square both sides. The step where I divided by 2 wasn't necessary. It just makes the number smaller to work with because everything was divisible by 2. That's why I did it. So on the left side, 2y minus 1 squared is 2y minus 1 times 2y minus 1. On the right side, I just have the square root squared, so I drop the square root and write 7 minus 2y. Okay, so now we multiply this out. 2y times 2y is 4y squared. Negative 1 times negative 1 is positive 1. Negative 2y, another negative 2y gives me negative 4y. And I've got 7 minus 2y. So we'll start at that point. Now this is what we call a quadratic equation because one of the variables is squared. So I need to get one side equal to 0. So I'll move everything over to the left. So that means I need to add 2y to the negative 4y and get negative 2y. I need to subtract this 7 from the 1, and that gives me negative 6. Now I'm going to factor the left side. There's a common factor of 2, so I could factor the 2 out, or I could divide both sides by 2. And it's much easier this way because 0 divided by 2 is still 0, and over here I've got 2y squared minus y minus 3. Now I'll factor the left side. I need a 2y and a y, and then I'll put a 3 and a 1, and the 3 must be negative and the 1 and 2 must be positive. That gives me the negative y in the middle. So 2y minus 3 is 0, or y plus 1 is 0. So y is 3 halves if I add 3 and divide by 2, or y is negative 1. Let's check those. 2 times 3 halves is 3, plus 6 equals 7 minus 3 plus 1. And that one works out, and the negative 1 does not. So 3 halves is the solution.